This is a piece of surgical tubing. Inside diameter is 1/4 inch. Outside diameter is 5/16 of an inch. The water is just connected to a garden hose. And I'm just holding it up here and letting it hang down. I'm not wiggling it with my hand. I'm trying to hold it as still as I can. And the bottom is just wiggling away all by itself. Let me just make it a little shorter. So I'm holding a shorter length. You can sort of see it all at once now. It's wiggling not as much, but it's still wiggling. I can certainly see there's a little bit of a permanent bend at the end, which may be contributing. I believe this instability is just due to the flow through the hose and the curves in the hose. There's no nozzle. This is just a straight exit. Anyway, that's very interesting. This is the attachment. I'm trying to hold two things at once here. If I try to increase the pressure a little bit, it starts to bulge, and that bulge works its way along, so I don't know how long that would last. So I really can't increase the flow rate very much, but even with this relatively low flow rate, the end wiggles around. Now here's a much lower flow rate. And I'm not seeing much action this time. If I'm wiggling it, of course, I'm making it jiggle, but I'm trying to hold it still. Well, I cut off the end that was curved, thinking I was cutting it in a straight section, but there's still a curve. I guess the entire length of the hose is curved just from how it's formed and rolled. So I don't think cutting it off is going to help. Oh well. Alright, this is that same hose, and I'm holding it horizontal, so the curve is aimed down. And of course everyone will claim that the nozzle is creating a thrust, but there is no nozzle. Flow comes out straight, and it's the curve here which is causing the lifting force. As the flow goes around a bend, it pushes on the outside of the bend, which lifts it up. And on the inside of the bend, it's sort of reduced pressure, sucking up. I know sucking is not really sucking, it's just reduced pressure. The outside air pressure is higher than that. I'm trying to turn it around so it hangs the other way, but it flips around. Just the weight of the water in the hose prevents it. Oh, that's interesting. So even though I'm not making it flip anymore, it's flipping backwards and forwards by itself. The curve is sort of pointed upwards, and it flips from one side to the other. And I guess in top view, it's going sideways like that. Now let it relax back to where it was, so it's basically hanging straight, curved straight down, and it's nice and smooth. And I turn it, I'm twisting it until it gets vertical, so it wiggles around. I'm going to try and increase the flow rate just a little, but without causing the bulge in the supply line. Okay, now it's wiggling around faster. I actually don't know which way it is in relation to the curve. I'm making it curve down now, I think, and it's wiggling like crazy. Turn it around so it's aimed up, and it's wiggling around because it's sideways. So even with about 8 inches of free hose, this instability happens. It does not settle down and go straight. It just keeps wiggling. So if I make it a little longer, what happens? That's interesting. Wiggling, I think at a higher frequency, it's almost like in seeing a second mode. Two bulges along the length. Maybe high-speed video would be cool, but I don't know this camera has high-speed video. It's my cell phone. Back to holding it vertically. Doing the same thing, wiggling like crazy. I'm going to stop there. And since we're being talked about hoses on the ground where friction interacts, I've just tossed it on the ground over here. And when I just increase the speed a little bit, it starts that wiggling thing. I'm going to try and increase it a little bit more. So now it's of course wiggling. Now it's stuck at the wall. That's interesting. Move that little thing out of the way. So it's actually aimed uphill. I guess the curve of the hose is aiming it up. And I just move it out and let it wiggle a little bit more. Oh, you can sort of see these curves forming and then kind of whipping the way to the end. Let me turn it sideways. Let me just try, see if I can increase this. Oh, look, the hose is way expanded. I can't get it to go faster. I'll just back off here and stop it. That's just the water draining out. Okay. Okay, here's another interesting little experiment. We've got the hose connected with surgical tubing, 1/4 inch ID, that is inner diameter, 5/16 inch outer diameter. And I've got a bucket of water over here. It's filled about. That's about where it's filled to. I'm just going to lower the hose into the water. And look at that. It starts wiggling around all by itself. Oop, that one was cool. I don't know. I need a pool to go deeper. Pull it out, it stabilizes. I'm going to make it a little longer. See if it makes any difference. It doesn't really have room, it keeps bumping into the sides of the bucket. So it doesn't have room to swing the way it would if it was unconfined. As we've already seen, if I make it longer, it'll do it in the air. This is now not in the water at all, it's just hanging above. Put it in the water, and the tip starts whizzing around. I need to get to a bigger pool. This will be interesting. All right, let's go back over here. That's just the wiggling around in the air. All right.